Hi, today we will be solving Leetcode 2997, minimum number of operations to make array XOR equal to k. In this, you are given a zero index integer nums and a positive integer k, and you can choose any element of array and flip its binary bit to either 0 or 1. Like you can flip it just simply. If it's 0, you can change it to 1. If it's 1, you can change it to 0. Simply. And then you have to return the minimum number of operations required to make the bitwise XOR of all the elements equal to k. So let's see what's trying to say. Let's say here we have an input 2 1 3 4. Okay, 2 1 3 4, and we have k which is 1. Correct. So what we want when we XOR all these elements after changing their bits, after flipping their bits, it should be equals to 1. Simple. That's what we want. So first of all, let's see what XOR is. For XOR, if you have definitely you have two inputs in XOR. If it's 0 0, it gives you 0 as output. If it's 0 and 1, it gives you 1 as output. If it's 1 or 0, it gives you 1 as output. If it's 1 and 1, it gives you 0 as output. So what it says when both the signals are same, it's 0. When both the signals are different, it's 1. Correct. I think you have got till this, that when both are same, it's 0. When both are different, it's 1. Correct. So let's say we had some numbers A, B, C, D. Let's for example let's say we had a number whose binary representation is 0 0 1, which is 1. We had 2, we had 4. Correct. Then we are going to XOR all these numbers. Correct. And at the end, this resultant should be equals to binary representation of 1, which is 0 0 and 1. Correct. And when I do the XOR of all these elements, I will get 1 0 1 1 1 0. Correct. Here, what will I get? I'll get 1. Here, what I'll get? I'll get 1. Correct. This is what happening. This is what happening. So now, correct. So this is 6 and this is 1. The decimal representation of these binary numbers. Okay. So now, what we wanted these to be 0 0 1 instead of this. Correct. So you need to understand that if I flip these resultant values to make it 1, the number of times I need to flip the resultant bits I will be same the number of times I am required to change bits separately. You're getting me? I'm trying to say, let's say, okay, forget about this one. Okay. Let's say I'm trying to say I had three numbers A, B, C, and their XOR, total XOR. So I'm saying to change a bit here, let's say I want to make it 0. So total number of steps to change it 0 is 1. To change here in XOR. So what I'm saying, to change here in XOR, I required one step, correct? So I will be requiring same one step to change one bit out of three. If I change any one bit out of three, all these three, it will become 0. It will become 0. That's what I'm saying. Let me repeat. I am saying if I want to change this 1 to 0, if I want to change this 1 to 0, I have to just change any one bit out of these three. Correct. Let's check. Let's check. Let's say if I converted this to 1, What will be my resultant? It will be 0 instead of 1. Correct. If I change this to 1, my resultant will be 0. If I change this to 0, my resultant will be 0. So I can change any one bit, any single bit, and my resultant will be different. So when I am needing to change this to 0, this to 0, and this to 1, so how many bits I changed in total? 3. So how many number of bits did I need to change in all these three numbers? 3. Why? Because to change one bit here, I need to change one bit in any of it. So you're getting me? The number of operations required to change the total XOR is same if I do it independently. Same. You're getting it? So simple thing that comes out to be to solve this problem is take the XOR of all the numbers and see how many bits are different. Here, all the three bits are different, so the answer will be 3. Simple. Take the XOR of all the given numbers, find its binary representation, find the binary representation of k, and see how many bits are different. The number of different bits is just your answer. Simple. Let's code it. So what did it say? Find XOR for all the numbers, and then find how many bits are different. So how can I find? Like the simplest way to find how many bits are different is I can take this number, I can take this number, and I can XOR it. 1 1 0 0 0 1 1 1 1. So if I count the number of 1 present in the resultant of these two values, this and this, the resultant of every number, XOR of all the numbers, XOR k. If I find the number of 1 present in this value will give me the answer. The number of 1 present in XOR of these two. Okay. So what I'll do in XOR, I'll also add k. And then in this, I'll count number of ones. Number of bit which are 1. And how can I count if one bit is 1? I'll just check the most least significant bit if it's 1 or not, and then I'll right shift the number. Sorry, left shift the number. Or what do you call it? It's right shift. Right shift, obviously. Am I right or the number right? Sorry. Yeah, working fine. So that was the solution. I hope you like it. Thank you.